spirit of keeping to time, we've hit 10:30, so we'll kick off this session. My name's Sky and I'll be the chair this morning. We're looking at adaptive management, Anyway, we're going to introduce the first speaker of this session, which is Leonardo Durante. Leo works at the South Australian Research and Development Institute, and he'll be presenting on the Goolwa Pipi in South Australia.
Thanks, Kai, for the introduction. So my name is Leonardo Durante. Hello, everyone. I work at Sardi as a research officer, and today I'm going to be presenting some of our work that we did in the recreational Pipi fishery in South Australia. So let's get into it. So we did our work around the Sir Richard Peninsula, right there, by the town of Goolwa in South Australia, which is the state next to Victoria. And that's a very important region for recreational and commercial species, including Pipi. And that's probably one of the places in Australia with the largest abundance of the bivalve. Talking about Pipi, Plebidonax deltoides is a small edible saltwater clam, for you guys that don't know about the species, and thrives in high wave energy environments with good supply of phytoplankton and can reach up to 85% of the infaunal biomass in a certain environment. So it's a very important species for things like nutrient cycling and food webs. And as you can see here on this satellite image, this is a very productive region. This is a phytoplankton bloom recorded in January this year. So this high production is reflected in the productivity of the commercial fishery, which was valued at $6 million in 2019. Pipi can be used for both human consumption and as bait in other recreational activities. So it creates a link between this fishery and other recreational activities in the state and in Australia. As you can see in the map on the left right here, the resources are located spatially, with 26% of the fishing grounds allocated to recreational activities. Although recreational fishers are now required to report their catches, there is a bag limit of 300 pp a day and a minimum size of 3.5 centimeters. And because the recreational fishers are now required to report their catches, there is a need for this kind of on-site crew survey to estimate catch effort and understand a little bit of the fishery. So the objectives of this study was to estimate catch and effort for the recreational fishery of Pipi in 2020-21 fishing season, which runs from the 1st of November to the 31st of May. Also to estimate the size frequency of the harvested Pipi and understand demographics and behavior of the fishers that participate in the fishery. We also compare some of our results with the 2013 survey that was conducted in the same location. A little bit of the methods. So data was collected by interviews after fishing trips with fishers in access points throughout the beach. Days were used as the sampling units for the survey and were stratified using spatially and temporally strata. So spatially it was main site 1 here by the town of Goolwa versus minor sites throughout the beach, and temporally it was weekdays versus weekends and public holidays. So most fishers access the beach through main site 1 by the town of Goolwa, and most of the fishing occurs during weekends and public holidays. So a larger proportion of the interview days were allocated to those strata. So from 212 possible calendar days, we allocated interviews to 25 of those days. And then later on, those data from those 25 days were expanded to the whole fishing season. It's important to understand the difference in access that those fishers have on the beach to the resources. So for example, pedestrians only have access around that access point on the beach, while people driving cars on the beach, they can actually access from the main site 1 to the Murray River mouth here, which is around 10 kilometers long. So there is a difference in access there. And although cars can drive all this way and harvest Pipi in any part of the beach, they can only access the beach to the main site 1 here, so in and out. So by allocating interview teams in the main site 1 in both vehicle and pedestrian paths, we're able to capture those activities quite nicely. And the activities can be quite different, as you guys are going to see in the results section. So during the interviews, the following data was collected, was recorded: the number of people and vehicles leaving the beach on a certain day, the type of the activity, if people were fishing or not fishing, the duration of the activity, numbers of Pipi that were caught and weight, measurements of 10 random Pipi, also details on the fishing methods that were used and the demographics of the fishers that participated in the fishery. And some of our results. That's the right slide. So a total of 351 fishing parties were interviewed, totalizing 860 fishers that were harvesting an average of 216 pp per day. They're not using, most of them are not using any specific methods or tools to harvest the pp. They're just using hands and feet. And most of the fishers were male, which is a big difference from the last survey in 2013. When males only comprise 50% of the fishers in the fishery. So we estimated a total of 4.3 million pp's were harvested in 2020 in 11,170 days, totalizing at 68 tons, which is around 16% of the total pp caught in South Australia from all sectors. There was an increase since 2013 from 3.2 to 4.3 million of pp caught, harvested, and a really large increase in weight, actually. This disproportional increase in weight can be explained by the fact that the pp's that were caught, harvested in 2020 were actually larger than the ones that were harvested in 2013, as you guys can see on this graph here. And when we compare vehicles and pedestrians, people driving vehicles on the beach were actually harvesting larger pp's than pedestrians were. Fishers driving cars on the beach were also showing a larger catch rate and were responsible for 91% of the total catch of the pp on that year. So fishing grounds with easy pedestrian access can be depleted quite easily, which could be reflecting the lower numbers and the lower size of people being caught by pedestrians compared to vehicles on the beach. This reflects the importance of interviewing fishing parties, both driving vehicles on the beach and also pedestrians, to understand the fishing activities that occur on the beach. There were less interviews done with people in vehicles in 2013 compared to 2020, which could partially explain this difference in size observed between surveys. Another important result is that most people in 2020 were using pp for bait purposes in other recreational activities, which is, again, a big change from 2013, where most people were actually harvesting the pp for consumption. When you compare this for fishers traveling from all over South Australia, there was a larger proportion of the fishers in Adelaide, Central, and Hills that were consuming the pp instead of using for bait. This can have implications on the communications of food safety messages regarding things like shellfish toxins and E. coli to that specific population. So if you guys saw Ingrid's talk yesterday, I think, that's very similar to what she was talking about. Historically, pp has been used for bait, so harvested and used for bait in Australia, in South Australia. But with the introduction of pp to restaurants, mainly by Italian immigrants, it became a really popular item. So people started harvesting them for consumption more than bait, which that's what we saw in 2013. But we've seen a shift back into use for bait, which is quite interesting, and you want to understand a little bit more why that is. So we compile a bunch of data sets to try to understand these trends. So fishers can purchase pp from commercial fishing grounds and also imported bivalves to be used for bait purposes, but the access to those resources has been decreasing over time. So as you can see, this is wholesale price in black here of pp from the commercial fishing grounds, and that has been increasing quite a lot, almost doubling since 2013. And that's the imported volume into Australia of overseas bivalves, which has also been decreasing over time since 2013. So again, the access to those other resources that could be used as bait has been decreasing over time. And that could have pushed some fishers to go out there and harvest their own pp to be used in other recreational activities, which explain what we just saw in the previous slide. Another big difference is how connected the fisheries are among themselves in this day, and the availability and access to information today. So you can type Pipi, Goa, cockle on YouTube, and you can get information where to get cockles, how to get them, how to prepare for food, how to use as bait. So the information is out there, and everyone has access to it. Just to exemplify this, this is the number of households in Australia with access to internet. It's been increasing quite a lot, and that's the proportion of the population that actually has access to smartphones. So I think one of these numbers down here is 2013. So even from 2013, there is a massive increase in people using smartphones and internet, which increase the connectiveness among people and among fishers. Another example is the number of videos you can find on Google with the terms Pipi, Goa, cockle, and that's just for South Australia. So that's a massive increase over time as well. Again, that's available information that everyone can access. And this is the use of social media platforms. So that's the same terms being used in a social media platform in a recreational fishing group. And the connectivity among the fishers can actually change the fishery in terms of catch, effort, and how people are accessing those resources and where they're accessing. So I think those are really important things to take into consideration the management and research of those species and resources. So just to wrap up the presentation, so more Pipi and larger ones too were harvested in 2020 compared to 2013. In 2020, fishes were comprised mainly by males driving cars on the beach and harvesting Pipi for bait purposes, which was different than in 2013. These changes were linked to shifting the fishers' motivations and behaviors, which are likely related to supply and price of the bait and how those fishes were connected among themselves. So the complexity of these interactions among fishers' motivations, behavior, markets creates challenges for researchers and managers in the areas of recreational fishing, exemplified here with the case of Pipi. But this complexity is not all bad and can actually create opportunities for research and management initiatives in recreational fisheries. So I just want to say thank you to FRDC for the funding, Fish Care volunteers for the help in the interviews, the government of South Australia, SARDI. I leave my email here if anyone wants to get in touch or have any questions, and that's the link to the report. Thank you.
Thanks for that, Leo. Fantastic chat. I just realised I failed to mention at the beginning of the session the housekeeping, which is we will keep questions until the end of the talks in this session. So next up, we have Zach, who is presenting in lieu of Kieran Hyder. He will be presenting on the economic impact of charter boat catch and release of Atlantic Bluefin Tuna fishery from angler expenditure.
Thank you. Thank you. Click on here. Great. Hey everyone, as Sky said, I'm Zach Radford. I'm presenting in lieu of Kieran Hyder here. And not only am I presenting in lieu of Kieran, I'm also presenting in lieu of Wendy here. So this is a third-hand presentation. So yeah, I've only had less than 24 hours for these slides, with Kieran having to go home yesterday. So try not to judge me too hard on this presentation. But yeah, so what I'm going to be talking about today is some socio-economic analysis that we're doing of a catch and release fishery that's been developing for Atlantic Bluefin Tuna in the UK. So when you think about the UK, you don't really think about coming fishing for bluefin tuna, and that's because it's only a quite recent species in our waters, with climate change really driving a distribution change of this species. And because it's quite new to our waters, there's no real existing commercial or recreational fishery for the species. So we've got this quite unique and nice opportunity to build a new fishery from the ground up and try and do everything right from the get-go. Also, for anyone who works with tuna, you know you've got to have a quota from ICAT to actually be able to fish for it. And you might be wondering, how have you got this if it's a new fishery in the UK? Well, we've actually got this quota through our EU exit negotiations. But As part of this, and because we want to build this really nice new fishery that's good from the ground up, we really need to do some science to generate the proper evidence that's required to create good policy. So the way we've done this is through our CHART program. So CHART stands for Catch and Release Tagging. And so the results I'll be presenting to you today are on the CHART program that was run last year, with the fishery only just closing this year. I haven't got any results for it yet. They're pretty hot off the press. But the season in the UK runs between August and November. And the way we've designed this program is a real nice co-design approach where we've worked with both DEFRA, who are our policymakers, the charter boat operators, and the key stakeholder groups, or peak bodies, as you call them over here. Within the program, we're looking at a lot of the behaviour and welfare of tuna. So we're doing, as the name suggests, we're doing tagging to see where tuna are moving once they've been caught, and trying to assess the post-release mortality. But what I'll be focusing on here is sort of the socio-economic benefits of the fishery. Last year, we had quite a small number of vessels that were licensed to fish for tuna at 15, but they still took out quite a few anglers, with just over 1,000 anglers going out over 407 trips. And throughout those trips, they tagged 704 tuna in total. To get the economic impact, we've done a survey of the anglers that went out. So at the end of each trip, we've asked them to fill out an online survey where they filled out like sort of general profile information, so what their demographics are and what their household income is, as well as we asked them some stuff on what their opinions are of the fishery and what the benefits of participating have been. Within this, we also asked them to outline their spending so that we can calculate the total economic impact of the activity. And the way we do this is through several stages. And so we start off with this quite descriptive analysis, where we look at the characteristics of the people that participate, and then just quite briefly outline what the benefits are that they've listed and what their spend has been. We then take the anglers that have responded and aggregate that to a trip level, which then we multiply up by the total number of trips that occurred within the fishery. We then take all these economic figures that we've got and run them through what's called an input-output analysis. And for those of you like me that aren't economists, what that does is take away the imports and taxes from the figures, so you can actually figure out the total economic impact, how many jobs are supported by the fishery, as well as the gross value added to the economy. Something quite interesting that we've been doing as well is figuring out some counterfactuals. So for what this kind of is, and if you think about it in scientific terms, it's kind of like a null hypothesis. So what you're trying to figure out here is what the spend would be if the fishery didn't exist. So some of that spend would occur anyway, and you're trying to figure out what can be directly attributed to the CHART program. Having a look at this descriptive analysis of the results, we see we get an overall response rate of around 10%, but with some of the vessels that went out generating more responses than others, and some not actually generating any responses at all. The overall demography of those that participated is quite representative of what UK fishers look like, being generally older white males with a quite high household income. A lot of the people who participate in the fishery specifically travelled down to the southwest, where the fishery occurs, to participate in the programme, with most of them spending around 3 days down there and spending about half of that time actually fishing for tuna. When we've asked them what the benefits are of them participating, they've often cited improved social interactions and also improved mental and physical health, with some social interactions primarily coming from them generating new friends that they've been out on the boat with. Once we've taken the economic figures and raised them up, we've calculated a total expenditure of just over £500,000, with the vast majority of that, around 65%, being attributed to how much it actually costs to go out fishing for tuna, so around £349,000. Running these figures through the input-output analysis, so taking away all those taxes and import duties, we've calculated direct impact to the economy of £410,000, a total economic impact of £889,000, a gross value add of £189,000, and the fishery supporting 11 full-time equivalent jobs. But all of this analysis assumes that all the spending is directly because of chart, which might not be the case, which is where we come on to the counterfactual analysis that we've done here. So the way we did this is to ask the anglers what they would have done if chart wasn't actually available to them. And we've split this out into 5 categories. So would they go tuna fishing elsewhere? Would they just go generally angling elsewhere? Would they do nothing or do a different activity somewhere else? Or would they go angling in the southwest? Or would they do something else like hiking in the southwest? There's actually a 6th response that they could give where they'd just do nothing, basically sit at home so they wouldn't have spent anything anyway. And that was quite a lot of our responses, around 72%, with the rest of the percentages being those people that didn't respond in that way. Within the analysis, I'll just go through we've done some adjustments to the spending profiles of people, which you can see in this right column. So for example, if someone said that they were going to go tuna fishing elsewhere, what we did to attribute the spend that was due to chart is take away the accessories that they spent on participating in the fishery, which we then were raised up. So what this looks like is we get a total spend per trip of just over £1,100. So that's quite a large amount. So I didn't mention on the other slide, but around £1,300 was the spend per trip before we did this analysis. So it's actually 83% of the spending could be directly attributed to the chart programme. As with every survey analysis, we've had to make some assumptions. So what we've assumed here is that the respondents are representative of the population and also that the trips that were reported were a random sample. Also, this is the first year, the results I'm presenting are the first year of the pilot study that we've done. So the angler profile and the spend and number of trips may change with the fishery advancing in the future. So because of this change that might occur, the actual relevance of these results to future programs are unclear, but we're hoping with the survey that we've done this year that we should be able to figure that out. So we just need to be a little bit careful when using the numbers from this survey. So in summary, participating in the chart fishery in the UK provides those that actually do it quite significant social, mental and physical health benefits. And a lot of the spend by anglers can be directly attributed to chart. I should also say as well, a lot of the places in the UK where the chart fishery occurs are what are typically quite deprived coastal communities. So a couple of pounds spent there can go quite a long way to helping employment in the region. So, but just to give a quick outline, just a recap of what the actual results were, we figured out that the direct impact of the chart fishery is £343,000, a total economic impact of £742,000, a gross value added of £157,000, and 9 full-time equivalent jobs were supported by the fishery. But as I said, we need to just be careful when we use these results for future iterations of the chart programme, which we have actually expanded this year to a total of 25 vessels. So thanks very much for listening. I know we're doing questions at the end, and I'll do my best to respond to them, but if I can't answer them, I'm more than happy to pass them on to Wendy for whoever asks. Thanks very much.
Excellent. Thank you so much for that, Zach, and really appreciate the fact that you stepped up in lieu of, Kieran's absence. So really appreciate that. Next up, we have Alistair Becker, who's from New South Wales Department of Primary Industries and Industries, full stop, and he will be discussing enhancing recreational fisheries in New South Wales. Oh. Excellent.
Yeah, look, thanks for coming along today. As I said, I'm Alistair. I'm from New South Wales Department of Primary Industries. I've probably got the longest title, I think, here of almost any presentation. But essentially what I'm going to do today is give you a bit of an overview of the research and monitoring that I undertake in support of our Fisheries Enhancement Program in New South Wales. So if you're wondering, what is fisheries enhancement, it can mean different things in different jurisdictions. At least in New South Wales, we look to increase fisheries productivity or local fisheries productivity through management actions that target bottlenecks caused by either habitat limitation or recruitment limitation. So in terms of habitat limitation, we deploy artificial reefs with a focus in the last few years on these sort of larger, larger sort of offshore reefs you can see there. And in return, and in terms of recruitment limitation, we stock fish into estuaries. We're currently stocking 2 species at the moment, dusky flathead, which is the largest of the Platycephalidae family, and mulloway, and that's a little juvenile mulloway you can see in that photo down there. Now, I think it's really important to point out at the beginning of this presentation today that these are really this program is like an additional lever for fisheries managers, okay? It's certainly not the first tool in the toolbox that our managers go to in managing fish stocks in New South Wales. They're there to, I guess, complement, if you like, more traditional type approaches, such as like output controls, bag and size limits. We do a lot of habitat rehabilitation work in New South Wales, so oyster reef restoration, seagrass, mangrove restoration, that kind of work is also done. And this program enhances those more sort of traditional approaches, if you like. The other really important point, and this is something which Emma, who's in the audience here, and Matt touched on yesterday, is that in New South Wales you have to buy a licence to fish. And that licence generates revenue which funds this entire program, like the deployment of the reefs, the stocking, and as well as the research that we do, and it's a really great thing. Okay, so onto the monitoring, which I do. So, why should we do this? Well, there's a bunch of reasons, and I've kind of listed them there. I guess they're kind of in a little bit of a, order of importance as I see it. But first of all, it's really required to ensure that these enhancement initiatives meet their goals. So obviously you can't tell if an initiative is meeting these goals unless you're measuring something, okay? And this is something Matt touched on in his talk this morning, but it allows managers to alter their practices over time, okay? So if a particular management action isn't having the desired outcome, hopefully our monitoring will identify that, and the managers can then adapt or change their management strategies over time to hopefully optimise the outputs for recreational anglers. And there are examples of that, for example, with the dusky flathead, changes in how we collect our brood stock and the cessation of stocking yellow-tailed kingfish. And finally, it provides opportunities for stakeholders, or rec anglers, to be directly involved in the Enhancer program. And I'll talk about that a little bit today throughout the rest of the presentation. So what do we actually do? We do a bunch of things actually. I guess I'll break this talk up now into artificial reefs and marine stocking. So in terms of the artificial reefs, we do a lot of fish community monitoring with underwater video. Okay, stereo brubs are just underwater videos, so we do a lot of that. We look at the species composition on the artificial reefs, how that changes over time, the presence of recreationally important species, remembering again that this program is funded by those rec licence fees. We do a lot of acoustic telemetry or fish tracking. So we obviously put little transmitters in fish. We look at how long they spend at the artificial reefs, their movement patterns around the actual artificial reefs themselves. It also allows us to look at interactions with vulnerable or threatened species. Okay, so the department at the moment is, for example, tagging like a ridiculous number of white sharks, and eventually, they inevitably come in contact with our artificial reefs. A lot of them have these transmitters in them, and we can detect them on our artificial reefs. So I'm actually writing up a paper on that at the moment, looking at these interactions between white sharks and the reefs we have up and down the coastline. We've done a lot of hydroacoustic surveys in the past. I'm just going to park that one for now because I'll go into that in a bit more detail in just a moment. In terms of the marine stocking, again, we do a lot of acoustic telemetry work. In this case, we put transmitters inside hatchery-reared fish, so juveniles. We put transmitters in and we release them out into the wild, and we look at the habitats that those fish are using. And we can then hopefully identify important nursery ground type habitats of these species, and then we can then tailor our release program to ensure that we release fish directly into those habitats. So when we release our fish, we don't simply release them from the shore, we actually ferry them out to a specific location on the estuary and release them directly into those habitats that we've identified through work such as some of the telemetry kind of stuff. We look at the growth and the contribution of stocked fish to the fishery. This is where some of the citizen science work comes in. We distribute kits out to anglers. They take fin clips of the fish they're catching in the estuaries that we're stocking, and then we can use genetics to identify whether the fish that they're catching are stocked or not. And we back some of this up with some independent fisheries surveys as well. And speaking of genetics, we do plenty of genetic work as well. We look at things like population structure of the species that we're stocking to identify if there is any subpopulations and just ensure that the fish that are coming out of the hatchery genetically match those of the receiving systems. So we've done that with a couple of species now. And we do some more sort of fundamental type stuff, which I guess anyone should be doing in any kind of release program, just looking at the genetic diversity coming out of some of these hatcheries and those sort of really fundamental type of things. So what I thought I'd do now is just go through a couple of case studies, some recent work that I've been involved in each of the artificial reefs and marine stocking. So for the artificial reefs, this is a study that's just come out in the last couple of months in Fisheries research. We're looking at the small pelagic fish assemblages associated with our offshore artificial reefs. So within New South Wales, our artificial reefs sort of typically fall into two broad kind of categories. We have our concrete module reefs, which that's one of them there. It's probably a bit bigger than you think it is. That thing's about almost 5 metres tall. Okay, we typically deploy 20 to 30 of these modules, which collectively create a reef field. And then the second type we have is these steel structures here. Now these things they're really big. They're like in the size of like a small apartment, 12 metres tall. We typically deploy two of these, and they're separated by a few hundred metres. So we ran these hydroacoustic surveys, or basically echo sounder surveys, okay, to look at the fish assemblages, or the mid-water pelagic fish assemblages, which were associating with each of these two broad types of reef types. So we had 2 concrete reefs, we had 2 steel reefs, and we visited them on like a seasonal basis for a couple of years. And we ran these transects with our scientific grade echo sounder. And this below image down here, this is a raw output. So for those of you who are familiar with a fish finder on your boat, you'd be well familiar with these. It's called an echogram. So this is an example of some of our transects. You can actually see these are the artificial reefs just here. So it's 30 metres deep at this site. And these big masses of colour here are the mid-water pelagic fish assemblages which are associated with that artificial reef. And we know that they were fish because on a number of occasions we actually dropped cameras down to confirm that. And so what we basically did is we basically mapped the density and the distribution of these fish around these artificial reefs. And it's a whole bunch of technical steps that we had to go through to do that, which we won't go into. But we modelled it using GAMS. And this is, I guess, some of the fundamental takeaway from this study. So what we have here with these graphs, I'm not sure I can point to this very accurately, but we have distance away from the structure on the x-axis, and on the y-axis the scale's a bit weird, but essentially it's just it is just fish density, so increasing density as you go up that y-axis. And you can see there's some pretty clear patterns between the concrete and the steel reefs. So we found with the concrete reefs, the density of fish dropped off quite quickly as you move away from those structures, whereas with the steel reefs, there was fairly elevated densities of fish all the way out to about 60 metres or so. And I think there's a couple of things going on here. The first is with the concrete reefs. Remember, there's a whole bunch of them, okay? There's 20 or so modules. So if one particular module got sort of crowded out, well, then fish could simply move to another one or another one, okay? So it's spreading the load a little bit. The steel reefs, they're massive, right? They're big structures. There's a lot of mid-water habitat, which I think is supporting just fish out to a greater distance. So why is this important? Who cares about these small pelagics? I mean, fishermen don't really go there to catch bait fish, except to maybe use for bait. So while we were doing our hydroacoustic surveys, we had an honours student, Aaron, that's him down there in the bottom right. Now he was doing some work on a species called blue-spotted flathead. Now this is a species that people do like to catch. They're easy to catch, they're pretty tasty, and we see a lot of them on our artificial reefs. So Aaron was doing some work looking at the residency and movement patterns of this species around a reef off Sydney. So he caught 50 of these things, he put transmitters in them, and he was able to track them around at a really fine spatial resolution around the South Sydney reef. And there's a bit of a mud map of it down here. So each of these black squares is a module, and that sort of pinkish kind of area is where Aaron found these blue-spotted flathead were mostly hanging out, so just to the northeast of that artificial reef field. So while Aaron was tracking his fish around, we were running our hydroacoustic surveys, and lo and behold, we found that the small pelagic fish assemblages were also mostly positioned towards the northeast of that artificial reef field. At the same time, we had a current meter in place that was measuring the speed and the direction of the water currents flowing over the reef, and they were coming in from a northeast direction. Now, Aaron didn't measure this, but we've measured it in other studies, and we know that these water currents are laden with zooplankton. Now, the small pelagic fish assemblages that we're measuring in our hydroacoustic surveys are zooplanktivores. They're feeding upon the zooplankton, and they in turn are actually getting preyed upon by these flathead, which are sitting on the bottom. And we know the flathead were eating these midwater fish because Aaron caught a bunch of them, had a look at their stomach contents, and sure enough, there was evidence of these bait fish within their guts. So we have this really nice, neat link here between these pelagic food resources in the form of this zooplankton, ultimately providing productivity for these benthic carnivores down through the food chain, through these zooplanktivorous fish, and it was really facilitated by this artificial reef being put in place. So I don't know about you, but I thought that was a pretty neat little story between those two. And that's in MEPS. You can read about Aaron's study in MEPS. Okay, last example now, and I'll boot through this one a bit quicker. Stocking example now. So another flathead species, dusky flathead. We're stocking this into a bunch of estuaries in New South Wales. Anglers love these things. But we had questions about exactly where we should target our release locations. So we had 30 of these fish we took from the hatchery. We put transmitters in them, and we released them into Lake Macquarie. So it's actually an estuary just by being called a lake. And we released them at this little blue square here, blue star. And we looked at their broad scale movements around the estuary as well as their fine scale habitat movements. So each of these little blue triangles, probably should have made that a different colour, listening stations where we could detect the presence of these stocked fish. And we looked at what they did after we let them go. And what we found was 3 of the fish moved down to the south down here, another 3 kind of moved to the north and northeast. So not massive numbers, but it does still represent like almost getting up towards 20% of the fish we release. So we know when we stock other estuaries into the future, we can expect these fish to disperse throughout those estuaries. The other really important point that we noticed was each of those sites where we detected fish had fairly extensive seagrass beds. So why is that important? Well, if we zoom in now to this release site, we had a whole bunch of other listening stations packed in really close together, which allowed us to get really fine-scale positional data, similar to what Aaron was doing on the artificial reef. We managed to generate just under 5,000 positions, and if we overlay that on that map, we can see that 70% of them were within 10 metres of the edge of the seagrass bed. So there was this really strong edge effect occurring there. And we know this is like a common theme in ecology, there's sort of these edge effects that we see, but there was a definitely close association of these flathead with the edge of that seagrass bed. So now when we go and release these fish into the future, we target our release locations in a boat to areas where there's like a mosaic of seagrass and sand with lots of edges. And this is my last slide, sort of wrapping things up a little bit. You know, this I guess like more recent kind of monitoring work is still sort of in its early phases. We've only been stocking dusky flathead and mulloway for a couple of years now. So we're getting kits out. We've got sort of 50 odd kits out now to anglers. We've got a few hundred samples that have come back into us, the fin clip samples which are now sent off for genetic analysis. We're still waiting to get the results now. But we're really looking to expand this program and build upon this into the future and hopefully generate quite a good data set as we continue this stocking program into the future. And look, I'll just leave it there. There's obviously a heap of people who have helped out in generating this work, and in particular the Recreational Fishing Trusts, which funds all of this research. And thank you very much.
Thank you, Alistair, for that. That was fantastic. Very impressed with how well kept to time everybody's been for this session. It's incredible. So up next, we're going to introduce Lotte, who is a PhD candidate at the Department of Earth Sciences in the Division of Natural Resources and Sustainable Development. Oh, excuse me. And she'll be speaking to us about change is in the eye of the beholder. So thank you, Lotte. We've got switch monitor.
Okay, great. Thank you so much for the introduction. My name is Lotte van den Heuvel, and I'm a PhD candidate at Campus Gotland, which is a nice, neat little campus of Uppsala University in the Baltic Sea. And today I'm talking to you about the second paper to come out of my PhD work. And this focuses on fish stock trend perceptions of anglers at one of the popular salmon and sea trout rivers in Sweden. So first, a bit of an introduction. Why is it important to look at angler perceptions? Throughout this conference, we've been talking quite a lot already about citizen science and involving anglers in monitoring and management and research. And angler perceptions, they contribute to this knowledge that anglers accumulate of a certain fishery. Through their repeated experience in this fishery, anglers develop this knowledge through their own personal observations, but also the interactions that they have with other fishers and their observations. So there's a lot of different ways that we can gather this information about fishers' ecological knowledge through all of these different citizen science initiatives, for example, that we heard about this morning. And so we can collect information in real time through catch reporting and surveys. But we also would like to know about the past. And so especially in some of these data-poor fisheries, we use angler accounts of their experiences in the fishery to collect these historical perceptions of how the fishery and the fish stocks have evolved over time. But there are some concerns when we do this, because a lot of these perceptions are the result of a combination of highly personal observations, understandings, interpretations, and evaluations of what is going on in this fishery. So we really need to understand what shapes exactly these perceptions that anglers might have of the fishery that they're involved in. So I'm going into a bit less technical, more psychological angle today, and I will show you a few different factors in general that are considered to influence the perceptions that people have of their environment. So first of all, we have the external side, which is, for instance, the context that someone is fishing in. This can be the physical environment, but also the social setting, who are people fishing with, and their own personal history with the fishery. Then we have another external component, which is the target, or the fish itself. And there's all kinds of different components here that can influence how a person perceives the fishing activity, the fish, and how the fish is doing, and the health of the stocks. And as you know, every different angling experience is different. Every different catch is different. Sometimes you might not even catch anything at all. And all of these experiences feed into the overall perceptions that people might have of a fishery. Then we have the internal side of things, which is the perceiver, the person that is fishing. And I won't go into detail here so much, but there are also a lot of physiological components that feed into this, that feed into how we perceive our environment. But what I will focus on today is the internal side of things, and specifically the psychological side. So we also know that there's a lot of different beliefs, values, motivations, types of knowledge, experiences that feed into how people perceive their environment, and specifically also how they perceive fish stocks. So this is what I will be looking into in this study, in this presentation. So the question that I'm focusing on is, how do different psychological dimensions influence stock trend perceptions, and specifically also accuracy? So what I've been looking at is Mörrum's Kronolaxfiske, which is a salmon and sea trout fishery located in the south of Sweden, at this little circle there. And this is a popular fishing destination for both domestic and foreign angling tourists. So there's people traveling from all over Europe, but also outside of Europe, to come fish here. In our survey, we had respondents from 4 different continents. And to give you an idea of how many people fish here, every year in 2018, so pre-pandemic, 10,000 fishing days were sold for this specific fishery. So it's a huge undertaking, and it's divided up into these 5 areas. And so why people go here specifically is because this river is known for record-size salmon and sea trout. So as you can see in these pictures, they're huge fish. The potential to catch huge fish at this river is what draws people out. Then the other nice thing about this specific fishery is that it's seen only recreational angling since 1960. So all other fishing activities have been banned since 1960. And there has been a mandatory catch reporting program since 1970, which means that we have recreational catch data going as far back as 1970. Now, what did I do for this survey? I performed an online quantitative survey among the people that bought a permit to fish at Mörrum in 2019, and we had 277 responses to this survey. And we asked them a few things, but among other things, we asked them about their stock trend perceptions in the following way. We asked them to reflect back on the first time they fished at this river, and we wanted them to compare this to 2019. So basically to compare when they started fishing to the present. And we asked them about this on a -50 to +50% scale, so a strong decrease towards a strong increase for both salmon and sea trout separately. And then we also measured several psychological dimensions. So we also asked them about their general motivations to fish, catch orientations, their engagement in terms of avidity and in terms of number of years fished. And we asked them about their satisfaction about their fishing at Murrum. And so all of these statements, so these were these Likert type items where you can score on strongly disagree to strongly agree. And they were all specifically related to their fishing at this fishery. And then we also used the historical catch data based on the angler reports that we've had. So this is, in short, what that kind of data looks like. So from 2002 onwards, we have this very detailed data set, but before that, we only have the catch data per month, which the total catch, which we accumulated into a yearly catch for each species. Now, going into results, I will only show you the results for salmon here due to time constraints. But so here in this figure, you see the fluctuations in the salmon stocks over the years, over the period since 1970 up to 2019. The red line indicates the average catch. And so you see a lot of fluctuations, as we see usually with salmon stocks. There's a lot of different factors that can influence this. So a lot of these are natural fluctuations. And so the black line here indicates 2019, the catches that were reported that year. And as you can see, it's quite much below the average. And as you can see also in the last segment of this graph, that there has been a decline in the recent years. They have had some trouble with some diseases and some issues there. So it was, they were going through some rough times when we were doing the survey. Now, in the bottom graph here, you see the angler's perception. So on the y-axis, you see the perception scale, again, in percentage of change. So at the top, we have 50% increase in stocks as perceived by the anglers. And at the bottom, we have minus 50% decrease. And you see that the most of these data points are in the lower half of this graph. So the majority of the people that fished at this specific river in 2019 felt like the stocks had been declining since they were first fishing there. Now we also looked at, so we compared the actual change to the perceived change, and then we see that there were two blocks of years or two time periods where the anglers were actually quite accurate. So there was a positive correlation between the actual change and the perceived change. And this was in the 80s, people that started fishing in the 80s and people that started fishing most recently. And so one explanation that we could see here is that the people that started fishing in the 80s were overall also most negative. So that that corresponded quite well there. Because we see also that in the 80s, the graph is above that line. So in general, it was quite good fishing in that year. So 2019 was actually a lot worse than in that period. So they were accurate. And then we see in the recent years, this might be due to the fact that they generally had an easier recollection of what was happening when they started fishing, because it simply wasn't that long ago. So you don't have this memory decay over time. But since we had this highly skewed data set, we decided to proceed with looking into the effect of psychological dimensions by transforming the data into a binary variable, where we looked at whether people perceived a decrease, yes or no, and whether this decrease or perceived decrease was accurate, yes or no. And so here's a huge table with a lot of figures. My supervisor said, bring them numbers. They like that. So here you go. If you don't agree, then complain to him. But so this is what came out of this. So as you might see in the left column, that not all of the motivations and catch orientations are included. This is because of the fact that through our model selection, we found that these factors did not contribute significantly to the model. So that is why they're also not included in this table. But what I want you to focus on here is the red box there for, so we included the orientation for catching big fish and catching something. And we see that anglers who were more motivated to catch big fish were actually less accurate when it comes to stock trend perception, so estimating numbers of fish and changes in that. And when it comes to catching something, anglers that were perhaps more numbers orientated, they were actually more positive. So this is an interesting finding, that so we see that people that are more numbers oriented are also more accurate in assessing these changes in stock trends. Then we have another significant result here of the number of large fish caught. So anglers that were more satisfied with the number of large fish caught were also more accurate. So there might be a memory effect here, but exactly the mechanism that is going on here we don't really know yet. And then we come to engagement and avidity. So as we already saw in the previous graph of these perceptions, you saw that the anglers that started fishing longer ago were more in the negative, and you saw the graph going up towards the present. And we see that back in this part as well. So we see when we look at years fished and avidity, we see that there is an effect on whether they perceived a decrease, yes or no. So in this case, the way you should interpret this is that the anglers that were more avid and had more years fished, they were more likely to perceive a decrease in the stocks. So that is that. So now for some conclusions and implications of this research. First of all, I think I really want to highlight that the fact that people were more or less accurate, that doesn't mean that we should completely disregard any citizen science or anything that anglers are telling us, because we know from other studies that there are a lot of people that do find that angler perceptions are very accurate. So this is just one way to look at it, and I really wanted to stress that. But some conclusions and implications. So experience and age influence perceptions, and this is hinting towards something that we've seen also in commercial fisheries, and that is increasingly being recognized in recreational fisheries, is this idea of a shifting baseline syndrome. So that the time that you enter the fishery determines what is your reference point of how it should be. And this relates to this idea of everything used to be better, and that is something that we see a lot among a lot of our older anglers, is that they say, oh, when I started fishing, it was like fish were everywhere, they were jumping, we were seeing them, and now you don't see them anymore. So that is something that we've also was hinted at in our results. So then we saw that catch orientation and satisfaction influence accuracy, which hints at, again, the importance of looking into angler heterogeneity, also for looking into perceptions. And then something that I would also like to stress is that accurate historical perceptions are really difficult to capture at a high resolution, and specifically also quantitatively. So I also recognize that in a lot of cases, it might be much more informative to do interviews, to do this qualitatively, so also capture the fluctuations over the years and not just compare one year to another year. So we see there are some limitations also in our methods there. So what about other influences? So based on the results that we have here, there's a lot of other things that would be interesting to look into. For instance, as I said, these fluctuations are a significant event over the years. When you talk to the anglers on site, they will say, oh, well, in the 80s and in the 90s, it was so good fishing and it was amazing. And I remember so well that it was so great then. But they also talk about the issue with these diseases and with the dead fish washing up on shore. And a lot of people saw that. And we're also talking about that on social media. A lot of people were sharing, oh, I found dead fish again in the last 5 years. And that will also influence how people perceive a fishery. So there's a lot of questions also around how social media, marketing, and catch reports that are openly available influence people's perceptions of what is going on in the fishery, something that we haven't yet looked into. And then finally, what I'm also very interested in is what are the consequences of having, certain perceptions? Does that change their behavior? Are people that are less likely, or people that have a more negative perception of what is going on in a fishery, feel like that the fish are struggling? Are they more likely to also engage in responsible behavior and stewardship and proper catch and release? So there's a lot of questions that are still unanswered, and I hope to get into in the future. And thank you very much for listening. This is the paper.
Thank you very much for that, Lotte. So we're into the last presenter of the session. We've got Matthew McLellan, who is from the New South Wales Department of Primary Industries as well, and he's going to be discussing FishGen with us. Thanks, Matt. Usual deal, slide, pointer, and I'll stand up for 30 minutes.
Thank you.
Sorry.
Yep.
Here we go, sorry.
Oh.
Should have done that for you.
Oh, we've got to click
Terrible
that.
business for me. We might need to click back. Here we go. We'll go. Yeah, apologies, Matt. Sorry, I should have done this for you. It was terrible housekeeping of me. There we go.
Welcome everybody, and thanks for coming along to listen to me. I'm Matthew McLellan, and similar to Alistair, I'm at the New South Wales Department of Primary Industries, where I'm a fisheries manager, but prior to that my background was in fish breeding and running the hatchery and breeding program at Narrandera for many years. Also like to acknowledge Megan Duncan, who is a geneticist with the New South Wales, a research scientist, but focuses on genetics and fish genetics at the New South Wales DPI, and also Jared Lyon from the Victorian Government, works at the Arthur Rylah Institute as co-contributors to this talk. And yeah, that's my 12-year-old daughter up in the corner releasing some fish with me one day not too far back. So the background to this, there's a lot of fish stocking happening across New South Wales and across the Murray-Darling Basin. So to have a sustainable fish community, we require fish across all the life stages. That's eggs and larvae, young of the year, juveniles and adults. So to make sure that you've got a functional fishery and fish stocks, recruitment's the key. When you've got limited or no recruitment, that results in an unsustainable population. And that's where often fisheries managers, such as myself, can institute stocking programs to help address some of those issues. I'm speaking just on behalf of New South Wales here. So fish stocking is a very big part of the management measures that we do in New South Wales. So we're stocking a lot of fish across the state. That map shows the stocking sites that we're doing across the state. So as you can see, a state the size of New South Wales, there's a lot of fish being stocked. And mainly those are all in freshwater, but there is a beginnings of a saltwater estuarine stocking process getting going. So we really want to know, if we're putting all this time, effort and money into fish stocking, we want to know, are our efforts working? That means that we need to be able to identify stocked fish caught in the wild. If they are working, why? And if they're not, why not? So do we know that the fish are contributing to the population? Are they outcompeting resident populations of wild fish? And what's the impact of that? So to be able to answer these questions, we need to be able to identify those stocked fish from wild recruits. We've been a reliable method of discriminating those stocked fish from the wild fish has been sought for a long time. There's lots of tagging approaches, so things like physical tagging, so fin clipping or dart tags, coated wire and things like that. But they're a more limited process. It's very labour intensive, and you can't batch mark tens and hundreds of thousands of fish at a time in those areas. From there, we looked at chemical bathing, so there was things like oxytetracycline, alizarin, strontium and calcine. So calcine was the one that we eventually settled on as the marking agent of choice in the Murray-Darling Basin. So calcine's a dye, and you can see on the screen there, that's the process we used, an osmotic induction technique. So the freshwater fish went into a quite relatively high bath of salt water. And then, so they were osmotically challenged. Then they were put into the calcine solution that was at 0% salt, and that made them draw the calcine in. Calcine proved good, but there were some difficulties. It was expensive and hard to obtain, quite difficult to work with, to mix and buffer the pH. Stressful for the fish, and also stressful for the hatchery managers and staff. Added an extra day into the cycle of harvest stocking, and it made us need to consider alternatives. Some other problems that came up were also mark failure if the technique wasn't applied correctly. It doesn't allow you to identify which hatchery it came from. We just know that it was a stocked fish, but not from which hatchery it came from. And also whether the stocked fish are reproducing when they get to the wild. Also, calcine was initially thought to be a non-destructive technique in that the fish didn't have to be killed to see whether they were sampled, and we could detect the mark externally, but after a few years it was found that we had to actually go to odorless to be able to detect that mark, so it meant that became a destructive technique to have absolute confidence in it. From this, it led to the development of what is now FishGen. So the Murray-Darling Basin is where a lot of this stocking work happens, and that covers a number of jurisdictions across Australia. So we brought together people from all of those jurisdictions and recognised the approach that we needed to get a coordinated approach to marking of stocked fish. So the FishGen committee steering group was put together and did a background review in 2016, and that led to the generation of this, a national fisheries genetic resource program where we could look at genetic parentage analysis as an opportunity. And no doubt, as I mentioned earlier, I'm not a geneticist, but we all are aware of the power and the way that genetic techniques are advancing so rapidly and what we can learn from them. So how does FishGen work? As I said, I'm not a geneticist, but so Megan would be more appropriate to explain this, but the simple way that we look at it is we're working with the SNPs part of the DNA. So there were around 480 million sequences obtained across both species, so that's golden perch and Murray cod. They're Murray cod pictures up there. So they're the two most stocked fish across the Murray-Darling Basin. Around 25,000 SNPs were isolated and were screened to be used in a parentage panel, and that's just leaving the ones that were useful. So we've tested the early work tested panels on juvenile Murray cod and golden perch from the Narrandera hatchery, where we had known parentage. So with that, all juveniles were able to be allocated to the correct parents that they came from when we had known parents, and we had was assigned that parentage with greater than 99.6% confidence. So that was the first step and proved that this method was going to work. As I said, how does it work? Ask a geneticist, but you can see mum and dad, and there's the offspring in there. So that's it. The beautiful thing about it means that each individual is uniquely identifiable. We collect samples from all of the hatchery broodstock. We can match wild-caught fish, so when researchers go out into the wild and they're collecting fish, they're able to match those. No physical markings required, more cost-effective, non-destructive, and we can test hatchery of origin. Also presents some challenges though. When the program started, there was a large number of fish in existing hatcheries right across the basin. So we had to gather those fin clips and get the fisheries, the managers to encourage those hatcheries, so both government and commercial hatcheries, to do that. One of the challenges with that is the different breeding methods that are used with the different species. So golden perch are handled annually. They're brought in for a induction technique with hormone. So it's quite easy to get a broodstock off them when you're handling them every year, but Murray cod spawn naturally in ponds. So that means that they're unlikely to be moved around or handled by the hatchery managers. So that may only happen every 1, 2, or even up to 5 years. Having that large geographic area of the Murray-Darling Basin and all those different regimes with different management regimes and how they regulate their aquaculture and manage broodstock meant that how we approached each hatchery was different. So we found that clear communication was the best way around this, and we ran a lot of workshops and physically went and visited a lot of the hatcheries to help them to transition to this. We also encountered some difficulties with sampling the Murray cod DNA. For some reason that we don't really know, it seems to degrade very quickly in the standard techniques we were using. So that meant a lot of the initial samples had to be recollected. They initially were just a fin clip that was stored in ethanol, but we found with Murray cod that was quite difficult. So we have actually solved that problem. We've got a commercially available DNA preserving kit that we've moved to, and that's helped with the Murray cod. Also, another challenge is financing the program. So generally, currently it's working on a fee-for-service basis, where researchers that want to have samples analysed will have to pay for them. But we need to keep the hatchery database going for the whole program to work, and to encourage compliance and all the hatcheries getting all of their fish in. So this program isn't going to work if not every fish is in the database. We don't want to physically have an actual financial cost to the hatcheries, so we need to be able to support that from somewhere. Results so far. So it's quite interesting. Some of the things that I've found. So here, this is a map of New South Wales. So it's a little bit hard to see, but it's, yeah, basically the top of the page is Queensland, the bottom of the page is Victoria, and that's New South Wales in between. So one fish that I collected from in the Lower Darling River around Pooncarie, it had 17 other fish that were, 16 other fish, 17 including it, that it was related to at a half sibling or greater, half sibling or full sibling rate. And you can see the blue pins there. That's where I found where those siblings or half siblings have been collected from. So that's a very broad geographic area. So it's suggesting that these fish are coming from stock populations. Because what we do with our stocking program, we're managed under a hatchery quality assurance scheme in New South Wales, so we do manage the brood stock and genetics under those things, and a lot of that meant that we were managing those fish to try and make sure that we're getting wild fish into the program, because we don't want to have fish that are selectively bred for aquaculture. Because we're stocking to the wild, we want wild fish going back there. But this showed us that even though we're collecting fish from the wild, we may have been getting some hatchery fish. It led to an actual review of how we handled the genetics part of our hatchery quality assurance program. So it's been very informative of that. This is another map of the whole of New South Wales. It's showing areas where so FishGen detects relatedness amongst the fish, and this is a relatedness heat map. So these are regions that I've shown there that are showing where there's strong, the bigger the circle, the more related fish that I've taken from those spots. So you can see a lot of those spots are probably in areas where there would be a general lack of recruitment, so it's suggesting that those populations are stocked fish. The opportunities that are presented with FishGen means we've got better management of hatchery parents. So we've instituted a traffic light system looking at the inbreeding coefficient that's measured in those hatchery broodstock. So a red light no use, yellow light used with caution, and green's good to go. By knowing that relatedness, you know of siblings or related fish that might be in your hatchery, so you can avoid pairing them together. You're allowed, it gives us the potential to distinguish situations where stockfish have gone on to breed with wild fish. So it allows that the marking can move multi-generational, so it's not just with a physical mark, you're only marking the fish that's, that you release. This way we can look at it. And allows us to look at areas in the wild that have got low genetic diversity and or high levels of relatedness, and we can tailor our stocking program to enhance that gene flow. Gives opportunities for what's termed genetic rescue or assisted immigration by bringing in some new gene flow. Also important for maintaining social licence for stocking programs. It can be controversial in some situations, and we want to make sure that we're abiding by world best practice and demonstrating that by knowing the genetics of our fish. Thank you. Lots of other applications, so I'll quickly skip over this, but some where this FishGen technology can be looked at population structure of a threatened species like Macquarie perch that's very widespread, and we can look at using that, what I was talking about, assisted gene flow and tailoring your stocking to help those fish move around. Lots to acknowledge here, and it's all due to the FishGen Steering Committee, which has been around for 6 or 7 years and worked really hard. And they're all the organisations that we're involved in. So you can see that it's a very eclectic group with a lot of representatives from a lot of agencies, but it's been a wonderful group to work with, and I think we've had some great achievements there. And also acknowledging Flinders Uni Molecular Ecology Lab. They're the service provider that maintains our database and does the analysis. Thank you.
Okay, thanks Matt for that. And can I just have a round of applause for all of our speakers for this session, and I'll get you all to come up to the front seats. Looks as though we have about 5 minutes worth of questions. Now, Jean, you're all good with the mic? Excellent, thank you very much. We'll open the floor up to some questions for our speakers. Seems as though you've explained it very well, speakers. Thanks, Rob.
A question to Matt. What is the cost of the dye?
So the dye, it was probably hard to, probably hard to calculate exactly, Rob. We were actually giving a payment to the hatcheries to consider their time that they were doing it, and I think that was a few cents per fish they were getting, but the actual dye itself was about $20,000 a kilo. So to do one batch of about 20 to 50,000 fish, it was about 100 grams. So you were looking at $1,000 to $2,000 just to do a batch of fish. So that was an expense, and as I said, it was difficult. So this is why we're moving to the FishGen. So the process that we're doing with FishGen, the cost of that is still sort of coming out, but it's I think we're looking at around about $100 a sample to have that done. But hopefully the more and more this happens, we see a decline in that price as well. But yeah, certainly fundamentally it's a much better approach financially and for value and the use for everybody involved, basically. Thanks, Rob.
Just another one for Matt. Do you envisage that when the researchers are in the field that they'll be able to simply take a swab, or they still use our kit to take the puncher sample? I was thinking that citizen science stuff, could an angler take a swab, preserve it and send it back for that info in future?
Thanks, Steve. Certainly currently they have to do a fin clip, and that's the important thing. So some of that stuff probably comes with its own challenges too. Alistair could attest to with animal care and ethics in research, so people needing to be trained appropriately before we can't just send people out willy-nilly. But that's the amazing thing with genetics. I mean, we can see how fast that field has moved in recent years. So whether we get to that stage where we can just do a swab, I'm sure that that'd be amazing and make application so much easier. But yeah, watch the space, I guess. And the exciting thing, Megan, my co-author on that, she does a lot of environmental DNA. So that's where they're just sampling water, literally taking a water sample, and they can distinguish what species are there from that. So, yeah.
I was just wondering whether there's been any discussion amongst the committee about whether this technology can be used to, I suppose, keep a database of wild breeders in rivers, and therefore being able to look at the dispersion of offspring and connectivity between populations.
Definitely that's something that's on the cards, Craig, and it's basically just going to we just need to get that database built, increase. And the more samples we get into it, the more power it will have. So that's it. You're going to be able to start seeing those techniques. And it's going to be really useful for informing all sorts of management, but especially around hatcheries, so we know this is a good wild recruiting population, so that's a good place we can send hatcheries to collect broodstock if we want to capture those wild genetics.
Okay, we have time for one more question, Ingrid.
I didn't see all the talks, and I won't ask Matt, but I did see Lotte's talk. So I was wondering, Lotte, you talked about people's perceptions of the past. Would you be able to say something about how baseline shift, but also how people look at the past and whether they're accurate actually influences their current behaviour? Like, what can you do with it for managers, for instance?
Thank you so much. Yeah, that's a really good question. And I think that is also definitely why it's so important that we look at these perceptions, not just historical perceptions, but also their perceptions of the current situation. Because perceptions they feed into the attitudes that we have about management as well. So if we see that something is happening, or if we perceive something to be happening, because this is a tricky thing, like everybody perceives things differently. But that is feeding into what we then do. If you see, if you have this idea that, this fishery is struggling, then that means that I have to be extra careful. That is what we're hoping, and that is what we are seeing in other pro-environmental behaviour studies, not necessarily in the context of fisheries, but in other contexts. So it's definitely very important to look at it both in historical sense and in the present sense. I hope that answered your question.
Are there any more questions from the floor for our speakers? Well, this is incredible. I think we're the first session to finish up more than on time. So I'd like to thank all of the speakers that we had for this session, and thank you all for coming to Room C. Enjoy an early minute, everyone. Thank you.